what people seem to not understand is bad connections don't cause fires directly. Bad connections could sit in your wall for 50 years and not be an issue. You could have arcing in your wall. It's not really an issue unless a lot of power is drawn through it, right?
I'll bet that a majority of people have never considered what's in their wall wiring going to their systems.
It's actually a pretty big issue, especially on older homes.
I was actually just thinking about it now that we brought it up because, like, yeah, my computer, I have no idea. It could be on, like, the bathroom for all I know because my house is pretty old. And yeah.
With the fan running in the bathroom and all kinds of noise.
Yeah.
Well, things are taking a lot more power now. More often than not, you have things like electric cars that people just plug it in the regular outlets and they consume the full capacity of the circuit for a day, hours straight.
Yeah.
You have computers taking way more power than ever, all the kinds of things like that.
Well, like electric cars in your garage. Like garages, okay, they put an outlet there. It's usually got a GFI, but, you know, yeah, they're not really planning on having it full load. You know, you might.
They weren't expecting it when the home was built.
Yeah, right.
And what that means was how most homes are built, especially older homes, at least in the U.S. You have one line, you know, a wire like this coming from the main panel.
Call it Romex.
Yeah, I mean, in the U.S., you usually use
Like
Romex,
14 gauge,
NM wire.
a three conductor 14. Well,
Yeah, it's white,
2 plus ground.
sometimes
but,
yellow,
Yeah.
but same concept as
15
that.
amp circuit.
Typically, yeah. And it comes from the panel. It goes to an outlet, right? It enters that outlet. It connects to the outlet. It goes back out of the outlet. So you have 4 connections in that outlet. It goes to the next outlet, the next outlet, and the next outlet.
They
Usually it
daisy
goes
it.
up, over, and back down between every outlet. So you think, well, this outlet's 3 feet away from the next one. There's 3 feet of wire. But there could be 20 feet of wire, 25 feet of wire, because it goes into the outlet. There's a little loss in the wall. It goes up, over, back down. It depends on the height
Well,
of
not
your
to mention
ceilings.
every connection point, which, how tight are those? Who put it
Yeah.
in? Is it 50 years old? Is it aluminum wiring?
Right.
There's
Well,
a lot of shit going on in walls that you're not aware of, you know?
the issue here is here's the real risk. A lot of people don't consider or really care about these things, what's happening in the wall. There's power coming out. They figure power's power, right? Every outlet in your house is not created equal. You want to ideally be as close as you can to the main panel because this wire isn't very large. There's other things on the circuit that contribute to additional losses, voltage drop, noise, and stuff like that on the line. If the outlets were replaced by homeowners over the years, which is pretty common, the connections might not be that tight. You might have one bad connection anywhere in this chain because there could be 50, 100
And
connections
the whole
in some
rest
old
of the
homes.
daisy after that is shot.
Right.
You could have arcing, noise on the line. So let's say, like you were talking about, where someone was plugging a computer.
Yeah.
Today's computers can draw over 1,000 watts at peak use.
Yep.
Mm-hmm.
And
know?
anybody anywhere else in the house could turn another thing on and it'd be on the same circuit.
And I mean, this isn't like you're plugging into a kitchen where most people, okay, they thought about that. You're plugging this into a bedroom, which is
Random
probably running off of, there's 3 other bedrooms, and who knows, maybe even you don't know what else is on the line. So now you're drawing 1,000 plus watts into a gaming computer in a bedroom that's daisied off of 6 other outlets going in 3 other bedrooms with TVs and flat screens and everything plugged
Well,
into
it doesn't need to be that
And
because
it's
I
just
didn't,
like, oh my God.
I didn't even think about it. But yeah, I mean, like I have like an amp and a DAC and my computer. Like, and if it's like a tube amp, it could take a lot of power. Adding on your monitor, there's a lot
Yeah.
of things on that one outlet already.
Yeah, the
So-
wall wiring's getting warm at this
Yeah.
point, right? It's physically warm because you're almost blowing the trip in the breaker, you know, because you're reaching the limits of the circuit, and you know, and that's, I mean, basically, even a modern home isn't necessarily wired for
No.
that.
No.
It's just not made. They don't think about how much power you could draw out of a bedroom, you know.
Well, it wasn't that long ago where the longest you would be drawing any power would be like a minute or two using a blow dryer maybe. So that's not that big of a deal because the frequency at which you're using something like this is pretty low, and usually you'd be using it in a bathroom, which is required to have a dedicated circuit, at least in the U.S. So that's not even an issue typically. But in bedrooms, they might have all the bedrooms in a house or all the rooms on a floor on the same circuit.
Especially older homes.
Very, very common.
You know, you might have 5, 6 breakers cover the whole house. The whole upstairs is on a breaker.
Yeah.
All the bedrooms are on another breaker. The living room's on a breaker. And the kitchen, if you're lucky, is on a breaker of its own.
Yeah, kitchen's supposed to have 2 breakers, but not always.
Yeah.
It doesn't always actually happen.
So it's, you know, you just don't know. And again, you know, if you bought the house, it's 100 years old, and obviously there's been multiple owners.
Yeah,
You
who
have
knows?
no idea what's in the wall.
Yeah.
You have until it fails, you don't have a reason to look at it, really. You know. So anyway, that brings us to today's topic, which is like maybe people better ought to think about considering running dedicated lines to their gear. And it's like we've been doing this in the 2-channel world for years. I mean, we actually created a category of cable called the Power AC in-wall, which is this big-ass red cable. It's a 10-gauge. It's UL rated, made to go from the main breaker panel to an outlet. So a dedicated run from your breaker panel to an outlet where you could plug in a stereo system, amplifiers. And we created this back in 2003. So it's been around 20 years. We created a category that was it's a high-end power cord that's just beefy, multi-stranded, blah, 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 made to handle all kinds of weird current draw. Whereas normally you're stuck with whatever you get out of Home Depot or whatever whatever you use in terms of Romex. So bottom line is that what we're saying is that we realized this a long time ago in the audio realm, where the in-wall wiring became a limiting factor to what these guys were using externally. You know, you start using big power cords, big amplification, right?
Yeah, and
now,
there's a 14 gauge in the wall.
Yeah, the bottleneck is the wall. And it's like, what options do you have there? Well, you call an electrician, and, you know, that's a start. If you're not familiar with doing this, absolutely get an electrician to deal with this. You know, they'll make it look easy, you know?
Most people are going to need someone else to do it.
Yeah, it's a good idea.
Right. So that's part of the barrier, though, right? Because a lot of people think it's part of the structure. It's in the wall. I don't know how to deal with it. But turns out there's people that you could pay that deal with it every day. And it's usually not impossible. Now, it does indeed depend where you live in the world, how your house is built. But a lot of times it's not that hard to run a new wire. And the cost could be, depending on the length, pretty reasonable. You could run Romex NM. You could run a dedicated circuit for your system. Might be a few $100, might be $1,000. And generally speaking, you're probably going to see way more benefits from that than you would like an audio power conditioner or something like that.
Yeah, like, you know, conditioners, they're made to do certain things well and help in certain areas. But if you have a wiring fault,
Right.
or if you have limitations in the wiring, it can't fix that. If you have low voltage coming out of the wall, unless you have a power generator.
Well, they're designed to fix things like that sometimes if they're fancy enough. But the better solution is to mitigate the first problem.
Yeah, solve the problem.
Right.
The root cause of the issue.
That's the smart
You don't
thing.
put a Band-Aid on a Band-Aid. You know, you can do it, but you're only going to get away with that so long before, you know, one of the Band-Aids falls off and then the whole thing comes apart. It's like painting over peeling paint. It's the same kind of concept, right? If the base
Basically,
layer
yeah,
peels
right.
away, it doesn't matter how much shit you put on top of it.
You could try, but it's tough.
Yeah.
Right. And a lot of these boxes and stuff that you plug in, they're made to solve voltage issues or noise issues, ground issues. But the best bet is to start with just a better connection. That's number one. And then if you think that it's still not enough, maybe you still have bad power quality in your area or whatever, then you can move up from there. But usually, even just putting a dedicated circuit of Romex in is a pretty good start. And if you want to move up, you know, something like this, a dedicated wire that's made for audio is a little bit better yet, but depends on your goals, your price point.
It's significantly more expensive.
Yeah, it's way
but,
more.
But in the end, if you're going to have it done and you're doing this and you have a lot invested in a system, who cares? I mean, you're not really talking about, you know, like some sort of astronomical chunk of change to run a really, really good dedicated line.
Yeah, you usually don't need that much of it, so it depends.
Well,
If
the
it
other
might
thing
be
that
30 feet.
experience has shown, like I've dealt with thousands of people with this over the last 20-some years, right? And what experience shows is that it's a problem solver, right? You got this stupid stuff going on, whether it be with the
Yeah.
computer glitching or, like you said, your friend's computer with the trip the breaker because his sister was using a blow dryer in the
That's right.
bathroom. You're gaming and the whole thing goes out
Yeah.
because they were all on the same circuit. But I mean, you just look at this and you're going, you know, people are having this issue and they live with it.
Right.
It just happens over and over again. And it can't be good for anybody. It can't be good to trip the breaker when you're peaking
No,
power on a computer.
it's not good.
At some point, that's not a good idea because you wind up with inductive surges in the line. You don't know what's going to happen when the breaker trips. That, you know, that sets up a potential surge into the gear when the power disappears at the breaker.
Actually, that is a point, though, because we've seen a few people blow up their amps or headphones from switching the power off to a piece of electronics
That's
that wasn't
right.
designed for it.
They're using a remote switch.
Yeah, we saw a couple of people with that. They had a remote on-off switch because they wanted to be able to turn several pieces of gear on or off together
Yeah.
easily because like the switch was in the back or whatever. And the trouble is you get potential for huge voltage spikes when you switch something that's an inductive load off. And it depends on how the device is designed and manufactured. But a lot of times in high-end audio, people that are designing the amplifiers aren't expecting it to be used like this, so they don't put protections in place to mitigate these. Usually, mass market consumer electronics, it's not a big deal. Usually, you could just switch them off, unplug them. It's not really a problem usually. But on some electronics, especially sensitive, fancy stuff, if it's not designed for it, it could be actually significant. It could be a problem.
And at the higher end, you've got, a lot of this stuff is still running linear power supplies. It's got big iron transformers. And when you suddenly remove power from them, they could kick back juice from the transformer into the line that everything else is plugged into. So if you got everything plugged into one strip, including this, one strip with a remote on off or whatever, and you turn the strip off, this amp, the field collapses in the amp's transformer, sends a counter EMF back through the line, goes into whatever else is plugged in the line. Let's say you got a preamp, a CD player. Well, that shit doesn't like seeing a few hundred volts instantaneously, and you do that enough times, or even a computer. You do it enough times, and something's going to give over time. It's just going to give. You're hitting things with hundreds of volt spikes that you just can't account for because that voltage has to go somewhere. And when you disconnect power, it's got nowhere to go but what everything else is plugged into the line. Anyway, there's all kinds of reasons why, dedicated lines, especially at the higher end of things, is really kind of critical to helping this stuff.
It's a good foundational element. And if you're running beyond just like a base setup, especially if you're plugging stuff in that actually consumes a lot of power, it's almost mandatory. And if you do it yourself, it's very affordable, but unfortunately that's kind of impractical for a lot of people. So it depends on your goals, but I think it's really a smart move if you have a high power system or a high-end system and you want to get the most out of it.
What'd you say in your garage? You were measuring voltages?
Oh, yeah. Well, that was the thing. When I first got my car, I didn't have I was just thinking about this. This is like worst case scenario.
Your electric car.
Yeah. And and the problem is I have a detached garage. So it's about 100. I measured. It's like 125 foot line to go to the garage, and then there's daisy chain like 5 outlets, and I was using the last one, so you could actually measure the voltage drop across the outlets. It was like 2 or 3 volts between the first one and the last one, and it was already about 6 or 7 volts drop from the house due to how long the 14 gauge was.
So now
and then had to go through all those connections. So actually, in the winter, it became a problem that's why I had to put in a dedicated line, because those few volts were the difference between like just heating the battery and actually charging.
Yeah, right. Well, that's the thing, that's the other thing people don't realize is the tech involved. There's a lot of tech involved with the way things work nowadays that it's invisible to you. And you reach a threshold at some point in voltage, whether it's too high or too low, where shit doesn't work. It's auto-adjusting for that. It's saying, well, it sees that. It senses a low voltage condition, goes, well, I can't draw as much because something's wrong. It's trying not to burn your house down, basically, right?
Better electronics.
They thought ahead this, right? It's like, if I'm going to draw 1,500 or 2,000 watts out of the wall, it's got to be careful that it's not overloading the wall outlet and potentially overheating your circuit.
Yeah.
So I'm sure this stuff's looking at it. It's probably looking for arc faults. It's probably looking at all this stuff to make sure if I was designing a charger with an electric car, I would be looking at it.
Yeah.
It's very easy to do. And if it senses an arc or something, it probably even turns off because
the car does these things.
wrong.
It'll give you a little notice if the plug gets too hot or if it sees weird issues. And people all the time on forums post, "Oh, I'm getting reduced charging capacity." People say, "Is your outlet hot?"
Yeah, right.
What's your voltage? And it's always like 96 volts. Is that bad?
Well, it's nice because, like right from the app, it tells you voltage, so you don't even need you don't need any equipment or anything.
Yeah.
So you just
Well, that's assuming you know what that means.
Well, yeah.
Well, if it gives you a pop-up
A lot
warning,
of people don't know. It gives you a
Right.
little message because obviously people a lot of times don't really think about these things. They plug it in like anything else, and it works, but the reality is the circuit was not made to run at full power continuously, and it might be 100 years old. It might be 60 years old.
Yeah, I mean, especially with electric cars, I would highly suggest to get an electrician in there. If you're charging that in your garage,
You need it. You
particularly
really
if the garage is attached to your house, where if the fire does occur,
Well, yeah.
the whole house is going up. you better get a dedicated line put in there for the car. No, just do it. Don't even think about it.
It's usually
Just
not even that
do it.
expensive. That's the thing.
Right. I mean, can usually with the garage, usually the breaker panel's right next to it. It's usually the way houses
a lot
are
of
built.
times,
A lot of
yeah.
times it's like a 20-foot run. It would take an electrician a couple hours to deal with it. Bam, you know, and even then at that point you could have a 240 line put in.
Well,
Yeah,
of
then you
course.
could
It did
charge
a
10
real
times
charge.
faster.
Yeah,
Yeah.
you know. So
Well, yeah. Now the line is like 6 feet to the breaker. You know, so it's good.
yeah, exactly. So anyway, brings us back to audio. We covered a lot about everything else but the same holds true with the sound character of stuff too. I mean, all these limitations are audible. You start limiting the line, the voltage, what else is on the line. Is
Yeah.
there a flat screen TV on the same circuit dumping noise on it? If the system is noisy itself, like some of the gear can be, switching power supplies are noisy.
Computers.
You know, yeah, a line with a higher impedance, or really, you know, home wiring wasn't designed for that kind of noise. A flat parallel run of Romex simply wasn't made to deal with that kind of noise. You know, ground ain't ground in a house, and that's a whole nother topic
Oh, yeah.
altogether. The ground isn't made to carry noise away. It was designed to help people so that people didn't get electrocuted. in
So you
case of
didn't
a
die
fall.
when you touched a
That's
metal.
right.
Yeah, it just offers a path for power, and so your body doesn't get it. But it wasn't made to dissipate noise. You can't throw noise on a ground. So anyway, there's a lot of problems at the higher frequency levels of noise level that people don't relate to, and a lot of these problems do affect sound quality. And by running a dedicated line, even if it is just Romex, but particularly like a really, really good dedicated line like we make, I mean, it could be night and day, particularly on a higher end system. Where you're eliminating all these faults in the wall, that the unknowns are gone. You know you're going right to the main panel.
Well, especially at long distance too, because I
Agreed.
mean that's the biggest. That's why I was in worst case scenario with
Oh, with electric
last
car?
outlet,
Yeah.
and it was a detached garage, you know, and a 125-foot run,
Yeah.
14 gauge put in 60 years ago, you know.
And I mean, most electricians probably already know this. They've been
That's
through
so
this.
common,
They
yeah.
could look at it going, "Oh my God, we're going to be busy for my lifetime." They already know what they're going to see.
So many melted outlets.
Yeah, there's no question. Yeah, and potential fires and stuff like that go
Mm-hmm.
on with it. So you know, fortunately, the cars are smart, and they'll probably avoid that. I would think.
What happens is people use adapters, and the
Oh.
adapter then doesn't get hot. The outlet gets hot, but the car can't temperature sense the outlet because it's through an adapter.
Oh,
So yeah,
I didn't know that.
that's the trouble.
Yeah.
People are faking it to try to get faster charging.
Yeah, it's kind of like those
You
that
just
they
need a
still
circuit.
sell
Is what you need.
Yeah,
those,
right.
you need a new
a
circuit.
real circuit.
Yeah.
orange adapter things that get rid of the ground pin.
Yeah,
I don't
then
even know
it
why
can't
they sell
temperature
those
sense.
still.
Jesus.
you
Yeah,
know,
that's
but
not a good
They
idea.
sell them at Home Depot, big
Yeah.
bin.
Yeah, you don't want to fool your car. You don't want to fool a charging system with a battery that big. You know, it's bad enough just to charge a drill
anything,
battery.
yeah.
You know,
Well,
in a garage.
What people seem to not understand is bad connections don't cause fires directly. Bad connections could sit in your wall for 50 years and not be an issue. You could have arcing in your wall. It's not really an issue unless a lot of power is drawn through it, right?
Right.
Because what the bad connection creates is resistance, which will create heat only if power is flowing. So if it isn't really used or it's infrequently used, you won't get enough heating to start a fire. It's very low risk, but very high load for sustained periods, high risk. So that's why if you have high power stuff, you want to try to put it on a dedicated circuit. And for audio, it's kind of a good idea just to get all the other stuff out of the way, get the uncertainties gone, run a dedicated circuit. Romex is plenty good for most people, but if you want to step it up, obviously, there's options for that too.
Yeah, we have solutions for
Well,
that.
also the connection, you know, your outlet is important too.
Yeah.
Those 59-cent outlets.
Don't get those, they're
yeah,
junk.
they're not-
Yeah, especially if you're plugging a car into it. I mean, get an industrial grade outlet.
Yeah, they're like
physically
$6
says
an hour.
they're a lot
industrial
more.
grade.
They're a lot more,
You
but
know,
they're still
Go to an
Extra
inexpensive.
electrical supply house, tell them what you're doing. You know,
They'll know.
Yeah,
Yeah.
they'll say, "Here's the outlet you want," because
Yes.
they have thicker contact material, which means they grip the plug better,
Right.
which means they're lower resistance, and they hold that grip over the long.
They last so
term.
much longer.
Yeah.
Yeah.
Where a cheap outlet will just give up the ghost in a couple. It'll be loose, and then that looseness creates warmth and fires and all that shit. So
All the issues.
you don't want poor connections anywhere when it
Yeah.
comes down to higher power. So anyway, there's a lot more that we could cover with this. We could talk for 3 hours on it,
Uh-huh.
and but bottom
That's the
line is
broad
that
strokes.
yeah, it's if you got any questions, email us, call us here. You know, you'll probably get a hold of me, and I've been doing this for decades, and I got the solution for you. So anyway, thanks for watching, everybody. Take care of yourselves. Thumbs us up.